So let's get the given written in here. And remember, of course, the triangles on the lines mean that obviously those lines are parallel. And you know I like to just highlight the transversal in green. So I see they have all those, well, not all, but three of the angles numbered in the picture. Clearly, they want me to do something with the numbered angles. So here's where we have to know all of our special angle relationships. So there's a relationship between 1 and 3. What type of angles are those? Linear pair, and a linear pair adds up to, which, oh, look in the prove line. Supplementary line. Okay, so that's going to help me. I also see a special relationship between these guys. 3 and 2. What type of angles are 3 and 2? Corresponding. And what do we know about corresponding angles? Equals to each other. So I think if we try to combine all of that together, we're going to make it happen. Now, it doesn't matter if you start with the linear pair or the corresponding. We need it all. Now, just because we threw out the linear pair first, I'm going to start with that. So I'm going to say the measure of 1 plus the measure of 3 equals 1/8. And that was, of course, because of our linear pair. So that is our linear pair postulate. Good. Or LPP if you just want to abbreviate. Okay. Then I circled those ones in purple, which we said were corresponding. And you guys told me were congruent. So I'm going to put that in here. Okay. So I'm going to say angle 3 congruent to angle 2. I'm going to slide it up just a little bit. Corresponding angles. And technically it's a theorem, just like yesterday. If you put theorem on, great. If you don't, I'm not going to mark off for it, but I'm just going to get technical here about it. So I want to try to put this stuff together and show that 1 plus 2 are supplementary. And I think I can make it happen. But first, of course, I don't know if I put the 1 on this one. First, of course, I don't like the fact you have congruent and equal. So I'm going to put the lame step in, where if they're congruent, we're going to say they're equal. So that way we're both in equality style and can work on it. Now, what is your reason? Bless you. When you go from congruent to equal. Definition of, yeah. Okay, now remember the goal. We want to show 1 and 2 are supplementary. I think I can make that happen because I'm looking in my red equation here. I've got 1. Is there any way you could swap this out with 2? Yeah, we can just substitute it in. You guys don't need me, you got it. And I heard the reason already, substitution. Man, we're so close. Substitution. Okay, we want to put property of equality, then I guess. Okay, now I think we're there because if they add to 180, aren't they supplementary? Yeah, so I'm going to fill in line 6, our last one, our approved line, angle 1 and angle 2 are supplementary. And what is your reason? Definition of supplementary. Got it. All right, let's do this last one. Any questions on this one? Bless you, man. Everybody, oh, they didn't even give me like the okay statements. They didn't give me the setup here. Reason. Got it. Of course, I'm just filling in the given here. Nothing crazy. P is parallel to Q. And of course, notice you have, I'm going to just highlight them in red there. And my green transversal. Now, we're trying to prove the same thing. 1 and 2 are supplementary, but clearly we have different picture, different number angles. So again, clearly they want you to do something with those angles with the 1, 3, and 2 on them. So I'm looking at those, trying to figure out, okay, what's the relationship? There's a relationship between 1 and 3. What type of angles are those? Vertical. So what do you know about vertical angles? Congruent. So I'm going to put that in here. There's also a relationship between 2 and 3. What type of angles are 2 and 3? Consecutive interior. And what do consecutive interiors add up to? And we have supplementary. I think we're going to make those two things come together and make it happen. Okay, it doesn't matter what you put in first. I talked about the vertical angles first, so I'm going to start with that. I'm going to say angle 1 is congruent to 3. And that's vertical angle congruency theorem, or less abbreviated, of course, VAC. And then I'm going to put the blue angles I have circled. We said those were consecutive. So consecutives, remember, add to 180. So I'm going to put consecutive interior angle theorem. Okay. Now, I think we can do this in just a couple more steps. I think we're pretty close, but we have a little glitch. Congruent, equal. We need them in the same style. So I'm going to put the lame step in here. If 1 convert to 3, of course, they're equal. And you could have put this together. It doesn't matter as long as we have everything in our proof. So you could have swapped like 3 and 4 if you wanted to. It doesn't matter, okay, as long as you have it all. All right, def of congruency. All right, remember, we want to show 1 and 2 are supplementary. So I think we can kind of like the last one. If I can swap this out with 1, which I can do because they're equal, we're going to have it. So I'm going to replace this blue angle 3 with angle 1. Let me scroll this up a smidge. And again, what is that when you replace something? Substitution. Seems like a broken record, doesn't it? And I think we're there because, of course, if they add to 180, aren't they supplementary? Yeah. Angle 1 and angle 2. Supplementary. And what is your final reason you put for that? Definition of supplementary. Got it. Any questions on that? Okay.